We're going to do a little bit of work on the scientific method. And it's important as we begin to study this process that it is indeed a process. Scientific inquiry is not the specific headings that you will find in this presentation, though these are the headings that we'll be using to study scientific method throughout the next little while. If you were to encounter a science experiment from a different element of science, a different discipline within science, such as biology or chemistry or physics, each of those areas would use different headings to encompass the parts of the scientific method. So while we will be using these headings, please keep in mind that it is more of a process and that you may find other headings throughout the internet. Scientific inquiry is all about curiosity and questioning. And so it's important to note that our first step is identifying some sort of problem or a purpose to doing the experiment or asking the question. We want to make sure that in the problem we do ask a question. This should be framed in a way that it can be tested. Right from this step, we're trying to be as specific as we can be. However, in this step, we're often not quite specific enough. So a problem such as what keeps people awake, that's not very specific. We can't really test that. We could be looking at hundreds of thousands of different things. And therefore, that's not a great problem or purpose. Instead, we might choose something like what drink keeps people most awake. Now we've narrowed it down specifically to drinks. We can then search out a couple of different drinks to test. And so my problem might be stated as to determine which drink keeps people most awake. But I'm going to refine my thinking a little bit more from that. And I'm going to do that by putting forth a theory or a hypothesis. In this step, we state the experiment that we're going to conduct to test what we believe to be true. So we will be making a guess as to the result of our experiment. This will make your experiment even more specific. In the case of my mock experiment, I might have a hypothesis like, I think that coffee will keep people more alert late at night to answer math questions than Red Bull or tea. I've identified what I mean by alert, I've talked about which drinks in particular I'm going to test, and I have put forth a guess as to which one will be the best solution. But I still have to prove it. In order to prove it, we're going to conduct an experiment. And so we need to start off by listing the materials that we will require. This should be extremely specific again. We're going to list everything. And we're going to be specific about the measurements, how much of each material. In my mock experiment, my material section might be 250 milliliters of Tim Hortons coffee, black, so the sugar can't affect the solution. But that would mean that I'll have to have the same amount of Red Bull and the same amount of tea. Notice I've identified the brand, how long to steep it for, and again that it's black. How will I test alertness? Well, that'll be my 50-question multiplication fact quiz. Again, this is a made-up experiment. My procedure is where we get into the actual experiment. Here I'm going to talk about the steps to conduct the experiment, once again being extremely specific. The idea of a good procedure is that anyone else can replicate my experiment using only my notes. They wouldn't need me at all. So, if I was going to do my mock experiment, I might have something like ask 3 adults of average intelligence to stay up till 2 a.m. Get them to take a multiplication quiz, record their time and accuracy. Notice this is before they've drunk anything. I want to see if there's an improvement. Then, person 1 will drink 250 milliliters of coffee. They're going to wait 10 minutes for it to have an effect. And then they're going to take the multiplication quiz again, with the question order randomized so I know that they haven't memorized the answers. Step 6 is to record their time and accuracy. 7, though, is to repeat those steps with each of the other participants using the Red Bull, same amount, and the tea, same amount. Lastly, I want to compare the results for both the speed and the accuracy. So now we need to look at what actually happened. The results and observations section is where we do that. Here we're going to report the results in a mathematical way. We're not making any judgments about which one was best. This is often done in a graph or a t-table or some other mathematical area.
To go home, Section Jan to the office to go home now.
We also want to include things that we notice as part of the observations. Things that happened while we conducted the experiment that might affect the results. So here is a t-table of the results for my fake experiment. And I want to remind you I did not conduct this experiment. So before they drank, the person who drank Red Bull later did the test in 2 minutes and got 36 out of 50. The person who was later going to drink coffee did it a little bit slower, but was also a bit more accurate. The person who did it, who drank tea later, was actually the fastest and reasonably accurate. What we want to compare, though, is did each of these people speed up after they drank and get more accurate? Now, in my results and observations section, I'm not supposed to make any judgments. Just report the results, which you see in front of you. It's in the conclusion section that in paragraph format, we report the answer to our problem and our hypothesis. We talk about what happened in the results and what it really means. We also talk about how this might impact future decisions or future research. So here's a sample conclusion. So again, all three were faster, but it's interesting to note that the person who drank Red Bull actually got worse. The person who drank tea got a little bit more accurate, but it's the one who drank coffee that made the most improvement. So from this experiment, it seems that if you have to do math at 2 o'clock in the morning, it's best to drink coffee. But there are other factors, and we should talk about those in the discussion, which of course is our last step. And it's in the discussion that we would talk about any experimental errors, things that went wrong, maybe somebody snuck some Halloween candy, or future research that needs to be done. This would also be in paragraph format. So, having walked through the different steps, you try it. See if you can identify each of the steps of the scientific method, the purpose, the hypothesis, the materials, the procedure, the results or observations, and the conclusion, as well as some discussion about future research. Click on the video below. It's a Mythbusters episode where they do some testing. See if you can identify each of the steps. We'll be using this information tomorrow.